Okay, hello everyone. Today we are going to be starting with rules of probability. Okay, there are several rules of probability. Now the first we are going to look at is the axioms of probability. Now there are three axioms of probability. The first one is that the probability for an event to occur must be between 0 and 1. What does that mean? That means probability cannot be less than 0 and cannot be greater than 1. Probability of an event cannot be negative. Probability of an event cannot be greater than 1. That means we cannot have something like this. Probability of an event to be equal to 1.2. This is going to be wrong. And we cannot have probability of an event to be minus 0.5. This will also be wrong. Okay, so that's the first axiom of probability. Now, the second axiom of probability is that the probability of a sample space is equal to 1. What does that mean? There are certain events. The sample space means the total number of possible events. The probability for that to happen is equal to 1. Now, the third one is that for mutually exclusive events, if two events are mutually exclusive, then probability of A union B would be equal to probability of A plus probability of B. Now, what does that mean? Mutually exclusive events are events that cannot happen at the same time. They are events that cannot happen at the same time. Okay? The probability that I go to school plus the probability that I did not go to school will be equal to A union B. Actually, it will be equal to 1 in that case. Okay, so events that don't happen, that can't happen at the same time is what we call mutually exclusive events. Okay, now note that A represents event, then S represents sample space, which is the total possible events. Okay, now the second rule of probability, you should know that the probability that an event occur plus the probability that the event did not occur, this rule actually is called the complement rule. It's called the complement rule. Okay? PA means the probability that an event occur. PA complement means the probability that the event did not occur, and it must be equal to 1 when you sum those two. For example, if the probability that an event occur is equal to 1 over 3, then it means that the probability that the event did not occur, probability of A complement, will be 1 minus 1 over 3. And 1 minus 1 over 3, if you find the LCM or you use calculator, will give us 2 over 3. Okay, so that's the second rule of probability called the complement rule. The probability that an event occur plus the probability that the event did not occur is equal to 1. So it means that the probability that the event did not occur will be 1 minus the probability that the event occur. Okay, that leads us to another rule of probability called addition probability, or the addition rule. And what does this rule state? That probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Now that's not all about that. But if A and B are mutually exclusive events, I explained to you what mutually exclusive events, nothing is common between the two events. The two events are mutually exclusive if they cannot happen at the same time. Nothing is common between them. And then probability of A intersection B is equal to 0. So what does that mean? What does that lead us to? That means that probability of A union B is now equal to probability of A plus probability of B. This is only possible for mutually exclusive events. Now let's see an example here. Given probability of A to be 1 over 4, probability of B to be 1 over 3, and probability of A intersection B, intersection means what is common between A and B, is 1 over 6. Now the first question is to find probability of A union B. The second is to find probability of A union B if A and B are mutually exclusive. Now let's see. Solution. Now number 1 here. we have probability of A union B according to the addition rule is equal to probability of A plus probability of B minus probability of A intersection B. Now what does that mean? It is equal to probability of A is 1 over 4 plus probability of B is 1 over 3 minus probability of A intersection B is 1 over 6, which when we find the LCM here is 12. 4 divided 12 is 3, 3 times 1 is 3, plus 3 divided 12 is 4, 4 times 1 is 4, minus 6 divided 12 is 2, 2 times 1 is 2. So 3 plus 4, 7, 7 minus 2 is 5, so you have 5 over 12. So probably, okay, so let's look at the second question. We're asked to find probability of A union B if A and B are mutually exclusive. Remember, we say that for mutually exclusive events, the probability of A union B is equal to the probability of A plus the probability of B if the events are mutually exclusive. That means 1 over 3, 1 over 4, plus 1 over 3. Okay, if we find the LCM of 4 and 3, the LCM is 12. So 4 in 12 is 3, 3 times 1, 3. Plus 3 in 12 is 4, 4 times 1 is 4. Okay, so that gives us 7 all over 12. Good. Okay, so that leads us to the next rule, which is the multiplication rule. And what is the multiplication rule? The probability of A intersection B is equal to probability of A times probability of B given that A has occurred. So probability that event A has occurred times probability that event B has occurred given that A has first of all occurred, or probability of B times probability of A given B. Any of them is correct. Now, but if A and B are independent events, what are independent events? These are events that can happen at the same time. They do not depend on any other event. When you say probability of A given B, that's a dependent event. That means probability that A has occurred given that B first occurred. But an independent event means that it is not dependent on any other event. Okay, so for an independent event, probability of A given B is equal to probability of A. That means there is no condition for B. And probability of B given A is equal to probability of B, meaning there is no condition for A. Okay, so this resulting to probability of A intersection B is now probability of A times probability of B. Let's see an example. Given probability of A to be 1 over 2, probability of B 1 over 3, and probability of A intersection B to be 1 over 4, the question is, are A and B independent? Now, what is the condition for being independent? We say that probability of A intersection B must be equal to probability of A times probability of B. Now, from the question, probability of A intersection B is 1 over 4. That's what we have here. Compared with probability of A, which is 1 over 2, times probability of B, which is 1 over 3. After multiplying, we get 1 over 6. So you see, both events are not independent. If they are independent events, then the values must be equal. Probability of A intersection B must be equal to probability of A times probability of B. Now that leads us to conditional probability. Okay, conditional probability, when you have probability of A given B, it's the same thing as probability of A intersection B all over probability of B. Remember that probability of A given B, this slash sign means given, is a conditional statement. That means the probability that A will occur given that B has occurred already. In the same way, probability of B given A is equal to probability of B intersection A all over probability of A. Now let's see an example here. In a group of 100 sports car buyers, 40 bought alarm systems, 30 purchased bucket seats, and 20 purchased an alarm seat and bucket seats, an alarm seat and bucket seats. If a car buyer chosen at random bought an alarm seat, what is the probability they also bought what? Bucket seats. Okay, let's go back to the question. In a group of 100 spots, so the total number of sample space, so let me make a solution. The total number of sample space is equal to 100. Okay, now 40 bought alarms. Let me call that event A. For A to occur is equal to 40. Then 30 bought bucket seats. I will use that as B, and B is equal to 30. And 20 purchased an alarm seat and bucket seat. That is the number that purchased both alarm and bucket. That means probably number of A intersection B, and that gives us 20. Now from this value we have here, we can deduce that the probability of A is 40 over 100, which is also 2 over 5. Probability of B is 30 over 100. That's the number of B all over the total number, 30 over 100. That gives us 3 over 10. And the probability of A intersection B is equal to 20 over 100. 20 over 100. That is 1 over 5. Now, what are we asked to find? Look at the question clearly. It says, if a car buyer chosen at random bought an alarm seat, that's the condition there. So A is the condition. If. So the word if means is a conditional statement. A car buyer chosen at random bought an alarm system. What is the probability that they also bought a bucket seat? So it means we are looking for the probability of B given A. If A has occurred, then B should occur. So probability of B given A. How do I know it is given A? From the statement if. If a car buyer chosen at random bought an alarm system. Alarm system is for A, okay? So what is probability of B given A? It means the probability of B intersection A all over the probability of A. That is equal to the probability of A intersection B intersection A also means A intersection B. That's the commutative rule, is 1 over 5 divided by the probability of A is 2 over 5. Okay, so that is now going to give us 1 over 5 times 5 over 2. This inverts, okay, which is equal to 1 over 2, as 5 here cancels 5, so we have 1 over 2. So we have that our probability of B given A is 1 over 2. I hope you understand that. We are going to be doing more examples on that. Now the next rule, probability rule I have here is the De Morgan's rule. Now according to De Morgan's rule, probability of A complement intersection B complement is the same thing as probability of A union B. Intersection becomes union, all complement. And probability of A union B, all complement, also means 1 minus probability of A union B. The complement there is 1 minus. Remember, the probability that an event occurred is equal to 1 minus the probability that that event did not occur. In the same way, probability of A complement union B complement is equal to probability of A intersection B complement, which also means 1 minus probability of A intersection B. That's the De Morgan's rule. That leads us to the difference rule. Now, what is the difference rule? The probability of A intersection B complement also means probability of A minus probability of A intersection B. Remember, complement, we can use C or prime to represent it, so it's still the same. Now also, probability of A complement intersection B is probability of B minus probability of A intersection B. And you can understand this particular rule using your set diagram. Now look at your set diagram here. Now this is set A, this is set B. Remember, where they intersect is A intersection B. Now here means A only, that means only A, that's A intersection B complement. While here means B only, which is A complement intersection B, that means no A here. A complement means no A, so intersection B, only B. This is B only. And why this is A only. Okay, so now the probability of the whole of this now is A. Okay, so probability of A minus, if you subtract A intersection B from A, what are you going to get? You're going to get A intersection B complement. That's the reason we say that probability of A intersection B complement is probability of A minus probability of A intersection B. The same thing with B, the whole of B here. So the whole of B minus A intersection B now will give us this, which is A complement intersection B. Okay, now let's see some questions here. We are asked, given probability of A to be 0.2, probability of B is 0.7, probability of A intersection B is 0.1. We are asked to find I. Permit me to add to this question. Let me see, I. Let's also find probability of A complement intersection B complement. Okay, good. So the first one here we are asked to find is probability of A complement. And I've told you this is the complement rule. It's the same thing as saying 1 minus probability of A, which means 1 minus probability of A is 0.2. Okay, so that will give us 0.8. Now the next question we are asked to find is to find probability of B complement. And probability of B complement also means 1 minus the probability of B, which means 1 minus probability of B is 0.7, 0.7, which will give us 0.3. Then the third question we are asked to find there is probability of A union B. And we know, according to the addition rule, that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay, which is equal to 0.2 plus 0.7 minus 0.1, and that altogether will give us 0.8. Oh, that's good. Now the next question we have here, the next is to find probability of A intersection B complement. I've told you that this is the same thing as probability of A minus probability of A intersection B. Okay, so probability of A is 0.2 minus probability of A intersection B is 0.1, so that gives us 0.1. The next one is to find probability of A complement intersection B, and that is the same thing as saying probability of B minus probability of A intersection B, okay, which is equal to probability of B from the question is 0.7 minus probability of A intersection B is 0.1, so that will give us 0.6. The next question here we are asked to find is probability of A given B. So we have probability of A given B. Probability of A given B is the same thing as, based on the formula, probability of A intersection B divided by probability of B. Now probability of A intersection B is 0.1, probability of B is 0.7, so that's the same thing as saying 1/7. Okay, then we have probability of B given A, which means probability of B intersection A, okay, all over the probability of A, which is equal to probability of B intersection A is 0.1, probability of A is 0.2, that will give us 1 over 2, or if you like, you say 0.5. Now the next we are asked to find is, let's see here, probability of A complement intersection B complement. We have to find probability of A complement intersection B complement. Whenever you see something like this, De Morgan's rule should come to your mind. So we can still write this as probability of A union B all complement. That is according to the De Morgan's rule. According to the De Morgan's rule, which is equal to 1 minus probability of A union B. Okay, so that would be 1 minus, what did we get as probability of A union B? Probability of A union B here is 0.8, so that will be 1 minus 0.8, which is equal to 0.2. I want to believe that you understand all that we've done. If you have any question, you can always chat me up and we do something about it. Thank you.